In the boundless tapestry of our planet's memory, there are moments when the old world stirs, when the deep earth, silent for centuries, chooses to speak through violence and fire. It is in these moments that the illusion of permanence is shattered, and the veil between past and present is torn by the trembling of the ground beneath our feet. In the far eastern wilds of Russia, where the land buckles into the colossal ridges of Kamchatka, such a moment has just unfolded. A seismic convulsion of unimaginable force, a megathrust earthquake that reverberates not only through stone and soil, but through the very marrow of human understanding. What follows is the story of a great awakening, a chain of cause and effect spanning centuries and continents, a resurgence of fire after 600 years of silence. It began as all earthquakes do, in silence. Deep beneath the Okhotsk plate, where tectonic giants grind in perpetual conflict, stress is accumulated for decades, perhaps centuries. The Kamchatka Peninsula, a land of perpetual unrest, sits atop the Pacific Ring of Fire, where the Pacific plate dives beneath Eurasia at a rate of nearly 8 centimeters per year. A relentless, invisible motion, storing energy with the patience of mountain time. For the people of Petropavlovsk-Kamchatsky, for the scientists monitoring seismographs from Moscow to Tokyo, the night unfolded as any other in early spring, until the Earth ruptured in a cataclysmic release of energy. Magnitude 9.2 on the moment magnitude scale, one of the most powerful ever recorded. In that first moment, the ground rolled in liquid waves, roads split and buildings swayed with a dreadful grace. Power lines snapped, plunging thousands into darkness. The air filled with the metallic groan of twisted steel and the low, inhuman roar of the world remaking itself. In seismology labs from Novosibirsk to the United States Geological Survey headquarters in Reston, Virginia, alarms blared. Instruments registered accelerations and displacements that dwarfed all previous records in the region. The rupture zone extended more than 400 kilometers along the subduction interface, a break so profound that the coastline itself shifted by meters in some places. Tsunami warnings flashed across the Pacific, setting off a cascade of international alerts. But the true scale of the event was not felt only in the immediate destruction, for beneath the shattered landscape, in chambers of magma sealed by centuries of cooling rock, the shockwaves of the quake triggered a slow, inexorable transformation. Near the shadow of the towering Kluchevskaya Sopka volcano, a giant among giants in the Kamchatka volcanic arc, lay the ancient caldera of Bolshaya Udina, a volcano whose last breath of fire predated the rise of Ivan the Terrible. Its silence had become legend, its slopes overgrown with lichen and birch, its name a footnote in geological surveys. Yet, in the days and weeks following the earthquake, the earth whispered warnings in a new language. Swarms of deep earthquakes, subtle ground deformation, and a subtle but unmistakable increase in volcanic gases, venting from fissures unseen for generations. To understand this awakening, we must first trace the deep architectures of the Earth. The subduction of the Pacific plate beneath the Eurasian plate not only creates the conditions for immense earthquakes, but is the engine of volcanism in Kamchatka. As the descending slab sinks into the mantle, water and volatile compounds are driven off, lowering the melting point of the overlying mantle wedge. Magma forms, rising in plumes that feed more than 30 active volcanoes along the spine of the peninsula. Yet not all volcanoes are equal in temperament. Some erupt with clockwork regularity. Others, like Bolshaya Udina, seem to slumber beyond the reach of memory, their systems sealed by ancient plugs of solidified lava. But earthquakes of great magnitude are not merely surface events. Their seismic waves, especially the low-frequency, high-amplitude surface waves known as Rayleigh and Love waves, propagate through the crust and mantle, shaking even the deepest magma chambers. These oscillations can destabilize the fragile equilibria within a volcano, fracturing the plugs, stirring the magma, opening new pathways for ascent. In the case of Bolshaya Udina, the seismic tomography data collected by Russian Academy of Sciences volcanologists in the aftermath revealed a chilling truth. A new injection of basaltic magma had begun to rise from depths of more than 30 kilometers, its path lubricated by the fractures opened during the quake. The first emissions were subtle, a faint increase in carbon dioxide and sulfur dioxide detected by remote sensors. Then came the harmonic tremor, a rhythmic seismic signal that, to the trained ear, is the herald of magma on the move. Satellite imagery from the European Space Agency's Sentinel-1 showed inflation of the caldera, a slow but measurable lifting of the ground by over 15 centimeters in less than a fortnight. Thermal imagery revealed hotspots where snow melted in irregular patches, and the air began to carry a faint tang of brimstone. In the remote villages skirting the volcano's base, the elders remembered old stories, tales of fire from the sky and rivers running black. Scientists from the Kamchatka Volcanic Eruption Response Team, KVERT, led by Dr. Elena Karpov and her international colleagues, scrambled to deploy portable seismometers, gas analyzers, and drones equipped with spectrometers. Their task was urgent: to determine whether this awakening would culminate in a minor phreatic outburst, or if the volcano was poised for a major eruption capable of reshaping the land and threatening thousands of lives. The world watched with a mingled sense of wonder and dread. For the Kamchatka Peninsula, volcanic eruptions are part of the natural order, yet an event of this scale, triggered by an earthquake of such magnitude, was nearly unprecedented in historical record. The most infamous analog was the 1960 Great Chilean Earthquake and the subsequent eruption of Cordon Caul, an event that had taught volcanologists to expect the unexpected when tectonic and magmatic forces interact. As the hours stretched into days, the seismicity beneath Bolshaya Udina intensified. Small earthquakes, some less than magnitude 2 but occurring in tight swarms, migrated upward from 20 to 5 kilometers depth, a classic sign of magma ascent. Gas emissions soared, with sulfur dioxide fluxes exceeding 5,000 tons per day, rivaling those measured at Mount Etna during its most active phases. The ground deformation pattern suggested a complex intrusion, with magma forcing its way through a network of ancient dikes and sills. In the command center near Petropavlovsk, Dr. Karpov pored over the data, her face illuminated by the flicker of monitors. She was among the first to recognize the significance of a particular pattern. The ratio of helium-3 to helium-4 in gas samples had sharply increased, a fingerprint of deep mantle-derived magma. This, combined with the shallow earthquake swarms and accelerating ground deformation, pointed to an imminent eruptive phase. Emergency services began evacuations, herding villagers onto convoys of trucks and helicopters, their possessions limited to what they could carry. Yet even as the logistical machinery of disaster response rumbled into motion, the scientific community grappled with deeper questions. Could the earthquake alone have triggered this awakening? Or was it merely the final nudge to a process already underway? The debate reached fever pitch in the halls of the International Association of Volcanology and Chemistry of the Earth's Interior, IAVCEI. Some argued that the quake's ground motions, with peak accelerations exceeding 1 g in places, were sufficient to fracture the volcanic plug and open pathways for degassing and magma ascent. Others pointed to the years of subtle unrest, minor seismic swarms and sporadic gas emissions that had preceded the Megathrust event, suggesting a system already on the cusp. To unravel this mystery, geophysicists turned to numerical models, simulating the coupling between seismic waves and magmatic systems. The models, incorporating data from previous triggered eruptions, such as Mount St. Helens in 1980 and Japan's Mount Fuji after the 2011 Tohoku earthquake, suggested a complex feedback loop. The quake had not only fractured the rock but also changed the stress field around the magma chamber, lowering the confining pressure and allowing volatile, rich magma to ascend. In effect, the earthquake had acted as both catalyst and trigger, transforming a quiet, smoldering system into one poised for explosive decomposition. As the world's media focused its gaze on Kamchatka, the narrative expanded beyond the immediate disaster. The story became a lens through which humanity confronted its perennial dance with deep time and planetary forces. For 6 centuries, Bolshaya Udina had slept beneath snow and silence, a geological blink yet longer than many civilizations endure. Its reawakening, catalyzed by a quake whose energy release rivaled the combined yield of every nuclear weapon ever detonated, was a sobering reminder of the scale and unpredictability of Earth's machinery. Philosophers and poets found in the event a metaphor for the hidden tensions in all things: the long silences before the storm, the accumulation of imperceptible pressures, the sudden irrevocable transformation wrought by a single decisive moment. Scientists, for their part, saw in the data a call to deepen their understanding of the interconnectedness of tectonic and magmatic systems. The Kamchatka event, with its cascade of cause and effect, would become a case study in the annals of geoscience, a natural laboratory for testing the limits of prediction and the resilience of human societies. In the days following the evacuation, the first eruptions began. Initially, they were small, phreatic explosions as groundwater flashed to steam, sending columns of ash and gas a kilometer into the sky. These outbursts carried with them the signature of the ancient volcano: shards of obsidian glass, pumice, and crystals of olivine and pyroxene, relics of the last great eruption. The ash cloud, caught in the prevailing winds, drifted eastward over the Pacific, disrupting flights and dimming the sun in distant towns. But these were only the prelude. Within a week, the seismicity reached a crescendo. A deep rumbling tremor shook the land, and a fissure opened along the northwestern flank of the caldera. From it, incandescent lava fountains erupted, lighting the night with a baleful glow visible for dozens of kilometers. The eruption column soared to 12 kilometers, penetrating the stratosphere and injecting millions of tons of sulfur aerosols into the upper atmosphere. The spectacle was at once terrifying and awe-inspiring, a reminder that beneath the thin crust of normality, the Earth's engine is always running, always capable of resetting the balance in a single convulsive act. Satellite data from NASA's Terra and Aqua platforms, as well as Japan's Himawari 8, tracked the plume as it encircled the globe. Climatologists warned of potential short-term cooling in the northern hemisphere, as the sulfate aerosols reflected sunlight and seeded high-altitude clouds. The echoes of the eruption would be felt not only in the immediate devastation, but in subtle shifts in global weather patterns, harvest yields, and the delicate balance of the biosphere. Amidst the chaos, teams of volcanologists braved the ash-choked roads to deploy instruments and collect samples. They measured the temperature of new lava flows, over 1,100 degrees Celsius at their core, and sampled the gases for isotopic analysis. Each data point was a clue in the unfolding story, a window into the processes that shape our world. The eruption, though catastrophic in local terms, offered a rare opportunity to study the birth of new land and the cycling of elements from the deep earth to the atmosphere. The human dimension of the disaster unfolded in parallel. In the temporary shelters erected in Yelizovo and Ust-Kamchatsk, families huddled together, sharing stories and anxieties. The Russian government, backed by international aid, mobilized resources for food, water, and medical care. Psychologists and social workers tended to the displaced, many of whom carried memories of earlier eruptions or the long shadow of the Soviet era's environmental catastrophes. Yet there was also resilience, a sense that life, like the land itself, would recover and adapt. In the months that followed, Bolshaya Udina's activity waxed and waned. The main eruption phase lasted for nearly 3 weeks, after which the volcano settled into a pattern of intermittent explosive bursts and effusive lava flows. The landscape was transformed. New craters dotted the caldera, fresh lava fields sprawled across the slopes, and rivers rerouted by debris flows carved new channels through the ash. Ecologists began to document the first signs of recovery: mosses colonizing the cooling rocks, birds returning to nest on the still warm ground, and the slow, inexorable return of life. For the scientific community, the event marked a watershed moment. The integration of real-time seismic gas and satellite data had allowed for timely evacuation and, in many cases, saved lives. Yet the unpredictability of the eruption underscored the limits of our understanding. Models were refined, new theories proposed, and a global effort launched to monitor other silent volcanoes lying in wait along the world's subduction zones. The Kamchatka Megathrust earthquake and the awakening of Bolshaya Udina became a symbol, a testament to the power of Earth's internal mechanisms and to humanity's eternal quest to understand and coexist with them. In conferences from Reykjavik to Santiago, geoscientists presented papers dissecting every aspect of the event: the dynamics of triggered volcanic activity, the propagation of seismic waves through heterogeneous crust, the chemistry of deep-sourced magmas, and the sociological implications of mass displacement. Yet, even as the scientific analysis deepened, a more profound reflection took root. The event forced a reckoning with the fragility of civilization in the face of deep time. The 6 centuries of silence before the eruption were a reminder that human history is but a fleeting moment in the life of a volcano. The rhythms of the Earth, measured in tens of thousands or even millions of years, dwarf the cycles of empires and nations. The disaster, for all its destruction, was also a return to the deep cycles that have shaped the planet since its fiery birth. In the quiet that followed, as the ash settled and the land cooled, the people of Kamchatka began to rebuild. New villages rose on higher ground, their architecture adapted to the lessons learned. Flexible, resilient, designed to withstand both earthquake and eruption. Schools taught the science of volcanoes and earthquakes, imbuing a new generation with the knowledge and respect needed to thrive in a restless land. Memorials were erected to those lost, and festivals celebrated the survival and renewal of the community. The story of the Kamchatka Megathrust earthquake and the awakening of Bolshaya Udina became a part of the region's folklore, a tale told around fires and in classrooms, a reminder of the interwoven destinies of rock, fire, and humanity. It was a story of destruction, yes, but also of resilience, discovery, and the relentless curiosity that drives us to seek meaning in the patterns of the natural world. In the end, perhaps the greatest lesson was humility. For all our technology and knowledge, we remain creatures of the earth, subject to its rhythms and moods. The deep forces that shape continents and birth volcanoes are indifferent to our plans and ambitions. Yet it is precisely this indifference that compels us to learn, to adapt, and to find beauty even in the most violent transformations. The Kamchatka event, with its cascade of cause and effect, its fusion of destruction and creation, stands as a testament to the grandeur and mystery of our planet. It reminds us that beneath the surface of the everyday, the world is always changing, slowly, imperceptibly, until the day it does not, and the old Earth awakens once more. As the years pass and the scars of the eruption fade, the lessons endure. Scientists continue to monitor the restless volcanoes, refining their models and instruments. The people of Kamchatka rebuild their lives, their culture enriched by the experience. And the story of Bolshaya Udina's awakening becomes a parable for all who dwell on this restless planet, a reminder that we are, and always will be, children of the earth, shaped by forces far older and greater than ourselves. In the silence that follows the storm, there is a new kind of peace. Not the peace of ignorance, but the hard-won serenity of understanding, respect, and adaptation. The land will heal, as it always does, and life will return, transformed but unbroken. The volcano, having spoken, returns to its ancient watch, its fires banked beneath layers of ash and time, waiting for the next moment when the deep earth calls and the old world stirs again. The memory of the great earthquake and the awakening of Bolshaya Udina will linger in the minds of those who witnessed it, and in the annals of science, as a reminder of the interdependence of all things, the delicate balance of energy, matter, and life that sustains our world. In the end, it is a story not of destruction, but of renewal, a testament to the enduring power of nature and to the resilience of the human spirit in the face of the unimaginable. In the vast frozen expanse of Kamchatka, where the earth still smolders beneath a crust of snow and silence, the lesson endures, that in every moment of upheaval, there is the possibility of rebirth, that in every trembling of the ground, there is a call to listen, to learn, and to prepare for the mysteries yet to come. And so the story goes on, written in ash and stone, in memory and in hope, as the Earth itself spins through the ages, restless, beautiful, and forever alive.